We are going to be doing number 25 on page 473. Number 25 says, apply the exponent rules first, if possible, and then evaluate. So this is question A. The first thing that we want to do with any negative exponents is get rid of them. So in order to do that, you have to take the inverse. So now you're going to have negative 1 over 8 to the now positive 2. Plus, and you're going to do the same thing with this one because we don't want that negative, 1 over 2 to the power of now positive 6. Then you evaluate it. This will become 1 over 64 plus, and this will become also 1 over 64. And then you evaluate that, and it will become 1 over 32. For B, the first thing we want to do here is work within the bracket. So just like over here, you want to get rid of this negative exponent. So first we're going to have 1 over 3, same as before, to the power of now positive 3, but it's still to the negative 2. Divided by, take the inverse, 1 over 5 to the power of now positive 5. Next, you're going to evaluate within the bracket. So 1 over 27, still to the power of negative 2, divided by 1 over, and you evaluate 5 to the 5, so it becomes 1 over 243. Then, in order to get rid of this negative exponent, you're going to take the reciprocal again. So that means it will just become 27 to the power of positive 2, divided by the same old 1 over 243. This then evaluates to 729 divided by 1 over 243. Then, when you type this into your calculator, it will become 177,147. So now for C. So what we're going to do for C is we want to get rid of this negative exponent again. So we're going to invert the fraction. So now we're going to have 3 to the power of 2 over 2 to the power of 3, all to be now positive 2. Now whenever an exponent is raised to an exponent, that is a multiplication. So what you're going to do is 3 to the power of 2 times 2, which is 4, over 2 to the power of 3 times 2, which is 6. You just type that into your calculator, and what you're going to get is 81 over 64. And then for D, it looks complex, but all you got to know is which order to deal with the exponents in. So what you have to remember is when you're multiplying it together, you're actually adding the exponents. So if you just look at it from the exponents side of view, you're going to see 6 plus negative 3 minus 2. And you got the minus 2 from over here, where a division sign for exponents actually is a minus. This then is equal to 1, which therefore means that it's 6 to the power of 1, or 6. So now we're going to jump to 475, where we're going to do number 38, which says, consider right triangle PQR with side lengths PQ is equal to 5 centimeters, QR is equal to 12 centimeters, and angle Q is 90 degrees. First, for A, it says determine the length of side PR. So what you're going to do, because this is a right triangle, is you're going to go A squared plus B squared equals C squared. And then you just plug it in. 5 squared plus 12 squared is equal to C squared. And then that's going to be 169. And because this is squared, you're going to want to square root this. Make that equal to just C because you've square rooted it. And then this is equal to 13. Is equal to C. which therefore means that your hypotenuse of this triangle is 13 centimeters. So now for B, it says determine the 6 trigonometric ratios for angle P. So first we're going to write SOHCAHTOA according to angle P. So that means that you're going to have your opposite here, your adjacent here, and your hypotenuse here. Now you just go on and you write these 6 trigonometric ratios. So you start with sine, cos, and tan. So you have sine of P is equal to opposite over hypotenuse. So that's 12 over 13. Then you have cos P is equal to adjacent over hypotenuse. So that's 5 over 13. And then you're going to have your tan of P, which is equal to opposite over adjacent. So that's 12 over 5. And then, for the other 3, you just now take the reciprocal. So you're going to have cosecant P is equal to 13 over 12. So all I did there is reverse. And you're going to have secant of P, which is equal to 13 over 5. Once again, just a reverse. And then you're going to have tan of P, you're going to have cotangent of P, which is equal to 5 over 12. Then, for C, it says, determine the 6 trigonometric ratios for angle R. So now we're no longer looking at angle P. We are now going to be looking at angle R. So once again, write out SOHCAHTOA based on angle R. So this is going to be your adjacent, this is going to be your hypotenuse, and this is going to be your opposite angle. So you just do the same as above. So sine of R is equal to opposite over hypotenuse. So that's 5 over 13. Cosine of R is equal to 12 over 13. And tan of R is equal to 5 over 12. And then, same as above, you just take the reciprocal. So you're going to have cosecant of R is just equal to the inverse, so that's 13 over 5. You're going to have secant of R, which is equal to 13 over 12. And you're going to have cotangent of R, which is equal to 12 over 5. And that's all.